Okay, here's a little more about 2.3 using the remainder theorem. These are just two of the last questions, I think, on the homework. So the first one is, it's asking you to use the remainder theorem to determine if the given number C is a zero of the polynomial. So we want to know if something is a zero. So remember, you can use synthetic division. And the whole key is what do you get at the end? Because that is your remainder. So if you get 0 as your remainder, then it is a 0. Well, this is a weird C to use, so that's why I wanted to do this one. Remember that I don't have to change the sign because they're giving me the C. If they gave me the factor that said like x plus something or x minus, then I would have to do the opposite. So I need to put 5, negative 26, 146, and 136 because there's nothing missing. Bring down the first number and multiply. So I need to multiply the 5 by this whole thing. So it becomes 15 plus 5i. This is similar to when we did the square root one, where my next step is adding, but I'm only allowed to add the negative 26 and the 15. So I get negative 11 plus 5i. Now I need to multiply this times 3 plus I. So I'm going to do that down here because that takes a couple steps. So we need to factor or FOIL this out. So I multiply the 3 times both of these. And then I do the same thing with the I. Remember, when you multiply I and I, you get I squared, and that's something that we're then going to change in a minute. So I can put the 15i minus 11i together and get 4i. But this can also go away because I squared is really negative 1. So 5 times negative 1 is really negative 5. So I have negative 33 minus 5. So negative 38 plus 4i. Now I add these together, but again, I can only add the 146 with the negative 38. So I get 108 plus 4i. And now again, I have to multiply these two together. So I'm going to do that over here. So 3 times 108 is 324 plus 12i plus 108i plus 4i squared. We can put these two together and get 120i. This is negative 1, so that's really negative 4. So 324 minus 4 is 320. So we get 320 plus 120i. And now we add these together and we get 456 plus 120i. But that is definitely not 0. So if they're just asking me to determine if it is a 0, my answer is no. Now for number 2 down here, same idea. They're asking me, except instead of is something a 0, they're asking me, is this a factor? Well, the same rule applies that if I change this to its 0, if I divide negative 3 into this problem and I get no remainder, then that means negative 3 is a 0, which means x plus 3 is a factor. So you just have to be careful and make sure if they give you the 0 or the C, you use exactly what they give you. If they give it to you as a factor, then you need to change it. So 1, negative 3, 9, 4, and negative 8 are my coefficients. So I bring down the 1, multiply it by negative 3, add these together, multiply by negative 3, add these together, multiply by negative 3, add these together, and multiply by negative 3. and add. And again, all they wanted me to say was yes or no, so I can already tell the answer is no, but it is exactly 124 is my remainder. But since it's not 0, this is not a 0, so this is not a factor. So last one, what am I going to do to check if x minus 1 is a factor? I'm going to use the negative one. Bring down the 1, multiply, and add. Multiply by 1, and add. Multiply, add, multiply, add. This time we got a 0. So that means 1 is a 0, and x minus 1 is a factor. So yes. Okay, hope those helped. I definitely just wanted you to see how to start problems like these so that you weren't confused when you got there.